got a little bit of soldering to do tonight. This is a improvement on a capacitor discharge tool that I built a while back. This time I'm going to put it into a project box and actually do it nicely. There's a switch here for two different voltage ranges, and make sure this is visible. So the switch goes between two different resistance values, and from there through one of two diodes, LEDs. Those will go into the little holes on the top, with another resistor in the middle just to drain everything in case the voltage drops below the forward voltage of the LEDs. Any remaining current should go through this. This is going to be a 1 meg in the middle, and then the upper range, the higher voltage range, 60,000 ohms for 600 volts, and 7.5 thousand, 7,500 for the 75 volt range. And those should both end up around 10 milliamps coming through the two LEDs, whichever LED is correct for the current polarity, and then no more than 10 milliamps across this 1 meg here. Actually quite a bit less when you consider the forward voltage. Anyways, pretty straightforward circuit. Most interesting part is going to be actually packing everything into this project box. I chose one of the smaller sizes that I have, and actually had a little bit of difficulty finding an appropriately sized switch. This one is most of the depth of the box, so it takes up a lot of space, and I had to adjust my placement. First try put the switch too close over the contacts on one end or the other. It didn't really matter which way you orient it. So this is the second one. I'm going to use the other box for something different that needs a switch and two lights, which is many things, so I'm not worried about that. But on the 600 volt side, I need to send that through 60,000 ohms, and if I remember correctly, that goes up to about 8 watts. So need a couple of beefy resistors for that. The other side, 7.5, I think this is a, what value is this? This is 6.8, so it's going to be just a hair higher, maybe 11.5 milliamps, and these are about 15 milliamp LEDs, so no worries there. You could probably run about 100 volts through the low side, and these would survive. This one's much smaller, and the 1 meg is actually a little bit larger, almost larger than the LEDs. If I remember correctly, I haven't drilled these holes quite large enough, so I'm going to need to grab something to file those down or drill them out further. I might do that off camera. But switches in, and both of the contacts on the end are in, so just need to get everything packed in here and solder it together. Not really a whole lot to this one. Not necessarily going to recommend this design. It's something I just threw together out of originally random parts that I had lying around. This is the second version, like I said, and putting it in the box is a little bit of an improvement over the first, but still something I'm trying out. So if you want to build something like this, find some sources for other options. The schematic for this will go on GitHub with all of the other schematics for everything I build. So, gotta grab my wire and get started. This one will be interesting because, especially on the high voltage side, I want to use the heavier wires. This is some solid core here. Supposedly is good for 600 volts. But getting everything soldered and then placed in here is going to be pretty interesting. I think I Actually have better luck if I take the switch out of the lid first, and then we'll sort of place things into the lid, use the wire to hold them in place. If it's the solid core, that'll work pretty well. The only problem with that is that this actually screws into the lid, so I'm going to need to drill that out as well. I can probably do with the threads on here. These project boxes are ABS, so it's pretty soft. Didn't quite strip it out, but I can take care of that when I do the LED holes. If not, let's see if we'll push through. That'll wiggle through well enough for what I need here. Won't come back out though. Alright, set this off to the side. So the idea with this, shouldn't put this too far away, the idea with this is to have the switch placed right about here, and then, let's see if that will stand up on. Nope. Switch is going to go over on this side. Hopefully, using my little schematic here, I can get these two larger resistors across the top. I'm not sure which way I want to hook these up. These are some pretty hefty leads on them, so they're not the easiest to bend. But I'm thinking I'll come in to the switch, share the middle post of the switch, use the lower post, the not connected one here, for the low voltage range, and then the middle post will just be shared with this for the high voltage range. So in that case, I'm going to want to solder these together at this end, clip that off, and then we'll get them tucked in. It's a good join on those two, and then I need to clip that off. Should probably have a larger set of clippers for these. That wasn't too bad. Alright, those are pretty well stuck together. They'll certainly hold up. I think I might stick some heat shrink over the end of this, but not too worried about that yet. So now, using the schematic as drawn, bend this one over in this direction. This will definitely need heat shrink because that is a long ways to go otherwise. And then this one, like paper clips, will come down in this direction, and that will actually then loop through there. So based on the distances, it's like something like that is probably what I want. Let's see if this will go through. There we go. It's not too bad, but these are not supposed to come in contact, so that's definitely a little bit long. Need to move it over, and then probably going to need to put the shorten this and put the LEDs on top, so this will come sort of up like that. And this one is going to have to be quite a lot shorter. And again, these will all have heat shrink I'm not too worried about them coming in contact with one another. So this is quite the double barrel resistor here. It's going to be even more difficult to tuck in. I'll actually sort of lock itself in place. I don't want it to be locked in place yet, but it'll be handy when the time comes. Unless you're discharging a unless you're discharging a pretty substantial power supply, these will probably not really heat up enough to melt the plastic before everything is fully discharged. So with this layout, I have to make sure that the switch has room here. I'm going to bend this sort of over in this direction, and then that will give me a convenient place to put the switch. It's going to be some tight soldering to get all of that in there, but I think I can make it work. And then I should probably get the LED assembly put together before I attach it to anything else. So this one was already bent from another project. It doesn't really need to be for this. So I'm going to put that in the middle, and then these two. This is the worst direction to bend leads. Should sit like so. The tricky part is just going to be getting it with the right width here. Before I go too much further, I do want to make sure that these LEDs are the right direction. And this multimeter should be able to test that. Can find the right setting. Alright. And I want these to have the opposite polarity. So this one is right on the left. Just make sure I have that right. Yep, right on the left. So this one ought to be right on the right. I do not know my right and left. This one's on the right. This one is on the left. So that is the correct polarity for what I want here. And then these need to be actually quite a bit closer together. So, kind of like that. Need a measuring device here. Just start to. Looks about right to me. So this side, most of the power will have been dissipated through the larger resistors before it hits this side. So the actual voltage drop across this should never really be more than the forward voltage of the LEDs. I would expect this to be always taking less. The LEDs will start conducting. This is going to be the higher resistance most of the time, until you get below. I think these are 1.7 or something, maybe 2. I have to check the little pack. So now I'm going to try and tack these together without moving them out of place or burning my mat too much. That is going to be easier said than done. Now I think I can make this a little bit easier by taking the resistor and not fully wrapping it around, but just using it to sort of keep these in place. I have a wire helping hand somewhere. So I think that is upstairs at the moment, so I have to go and grab that. Alright, well, this very intricate monstrosity ought to work. Alright, that should do the trick. Pin this down. So this is actually on the upper side. It's probably going to have to go. It's unfortunate. I would have liked to use that as part of the lead, but this one is flat. It'll probably stick around. So this assembly is going to be right hand, and considering this is actually two resistors, sort of even number of components, we've got switch, two LEDs, four resistors, two contacts, one box. So now this needs to go in, and I need to grab some heat shrink to insulate this section. And this is going to go on one leg of the switch, so I'm probably going to do that first, and then the switch is going to go on there. So bring this sort of out in this direction, and then I'll leave the other lead just intact for the moment so that that can be replaced, moved later. Give that a quick twist, and then need to try and solder this at a pretty good 90-degree angle here. Otherwise, it's just not gonna sit quite right. It's a wiggly one. Alright, that's on there. This is just a problem waiting to happen, so I'm going to clip off that extra lead. Perfect. And this should just sit nicely right in there. And then, so this is sitting here. This resistor actually needs to come in contact with that. So I may have made this a little bit longer than it should have been. Looking at where the switch is going to sit. So that sort of contacts there, and then these two have to hook up. So this is definitely longer than it should be. started to get a little bit melty on the switch, but I think it should still work. It smells like a fishing lure. I'm going to clip this down because that was the issue, and then flip it over again, this time so much shorter. Looks like this is full of solder at the moment, so that needs to get out of the way. Might have to use a piece of wick on that. There's an acrobatic switch. Now, if we can do this correctly, the goal here is just sort of to get this through at a 90 degrees. And then I can bend it over. There we go. And that definitely just messed up the solder joint a little bit, but I'm going to reflow that afterwards, so I'm not worried about the integrity of the joint at this point. Just want to get that crimped around it, and then I'll take it back here and without a quick reflow. There we go. It's got a fair surface on it now. It's good to me. Naturally, I put it on the wrong side. Once more. Do this without melting the switch. Close now. There we go. It definitely needs a little bit more solder at this point. Alright. It's pretty good. Doesn't seem to be wiggling or anything, so I don't think that's dry. Alright. So that is going to fit here. Once again, it's going to come up. This is going to have a pretty sharp angle to it. This one is sort of like that. And then that's just going to sit in just like that, I think. So take quarters, like I said. There's not really a better way to do it, considering this has to be in place already. So let's get some heat shrinks going to there. A short piece of that. And unlock this. The heat shrink in place. And back up. Slide it back into place. And it's going to be difficult to make sure these actually stay completely out of one another's way. Let's see what I can do here. If I bend this down a little bit further, it might work somewhat better. And then I think I need to actually sort of attach the switch on that side first. I'm really going to pull this up with the switch in place. Now, I wouldn't call this joint structural by any means, but I think it will work. I think it will work safely for purposes of this device. Of course, when we closed up, there won't be fingers poking around in here, so there's some safety provided by that. But the orientation of this doesn't really matter. I think the easier way to do it is going to be this way, so I can pull this lead down. I put the resistor on the wrong side for that, unfortunately. So I have to sort of loop this back on itself. Not ideal, but that off at the end. And then it's going to sit just right in there. So tight quarters for sure. This twisted pair here is just a little too soldered to fit over the resistor. Or maybe not. Oh, worked until I smacked it. Alright, let's try that one more time. Sort of works. And this one, it's not really going to stay in place long enough to solder, I think. Alright, this one should come around here. And it's trying to get away from me. I don't want it to go in that direction. I want to give this a quick crimp. And then those need to be stuck together. This LED side is really giving me some trouble. Looks pretty good. And that should more or less fit. A little bit of a wiggle. And I think it's time to tack this other end down, coming up on the end of my solder. See if I can feed the rest of it. A little bit of a tail that didn't go in. Normally you can get rid of the last bit of solder if you sort of toss it into the joint, but just didn't quite work there. There we go. Thought a little bit flew away, but don't see it now. So, alright. So this can be clipped off as well. Clip this down pretty short here. Actually left a section that I don't really want. Alright, so now the switch is in place. And the switch, of course, just comes down to the smaller resistor. Less resistance, more current for that lower voltage range. It's got a good clicky action. And then this side, you need to get back in place. Get it through the red contact, as well as over the shared terminal. Alright, and then I'm worried that these lights are not going to quite line up where I want them, but the height of the shared terminal is also going to be a problem. That definitely is a little bit taller than it ought to be. This is the whole switch here. It needs to go down quite a bit. Okay, so with the switch pushed into place, make sure that nothing is inappropriately coming in contact. Heat shrink is going to definitely save that. Yeah. Hooray for heat shrink. Alright, so the switch is about flush now, so that should work a little bit better. This post needs to come, I guess, back down this way. It needs to be folded over one way or another. Right. And then maybe this will fit a little bit better now. I don't know if I would call that better, but it fits. Alright, need some more solder. And see if I can get this down into this post, or this contact on this end, without completely frying my resistor. Alright, it looks like all of the major contacts are in place. These LEDs are not quite where I wanted them, but let's see how that sort of fits. Yeah, they're definitely not in the right place. I'll either poke another set of holes or grab another lid or something. I'll figure that out. Anyways, let's test fit this. It's the worst way to put this lid on. Alright, good enough for now. Now the intent here is going to be interesting with the LEDs in place, so I probably don't really want this closed up yet. So if we have any amount of continuity end to end. No, it's not reading anything, so it's not a great start. Crack this open without messing anything up. Now, one handy thing about this design is that I can just go like this. I'm going to measure through there. Not reading anything. I feel like I'm not making good contact with the banana plug. I should really have a plug-in on this end. There we go, that's a bit more what I would expect. Bouncing around so I can get good contact. Come on. That is one confused meter. Where's my batteries dying? I'm working in at least one range, so grab a plug-in cable here, and then actually use this a little bit more reliably. So now if I go across there, it's a little way more stable. Alright, 6.1, what I want. And then the other range, 60.1. So 10-to-1 ratio between the two ranges. Seems like that part is working. And then let's move this back over to Diode Test, and I think for this I'm going to want a micro grabber. These little grabbers, and just get it in there. Because the two LEDs are hooked together, this should work just fine. So that lights one, and then switch sides, and that lights the other. Alright. That looks like everything is hooked up. I'll trim off some of these last few leads. And, yeah, can't really see in there too well, so you can pop the lid back off. So that's the inside of that. Just a lot of resistance, a little bit of switching. So, put this lid back on, and I will hook it up to the power supply. Test it properly. I think in order to test this really well, I'm going to run it through a Simpson milliamp. Wrong switch. So, if these are nice and all, I would like to see how much current is going through this. So let me grab a couple things. These are always fun, just for the low ranges. For the higher range, I am going to have to use this digital meter, I believe. 10 amps, yeah, that'll certainly work. Alright, let me get this plugged in. Power supply is fired up here, and run it through this first. From the other side of this discharge box. And then from the discharge box, this is the part that will eventually go through the other meter, but from the discharge box back to the power supply. Alright, so this is really just a electronic load, not a smart one or anything. I don't know if you'd call that an electronic load. It's a resistive load. And then a meter. So make sure I'm not going to fry anything. This is a 12 volt test, 100 milliamps max. 12 volts is enough to light up the LED. I think that is, oh yeah, that's pretty visible on camera. Barely see it going through here. 12 is within the range for the other, so there we go. Quite a bit brighter, and that's pulling a whole 2 milliamps. Matches the supply. So yeah, it's actually a pretty good test. You can see the change on the meter. Works nicely. Crank the voltage a little bit. 30 volts, pulling 5 milliamps. That's the low range. It's the high range, so that drops it down. So that works nicely. 5 milliamps at 30 volts, and I'm expecting about 10 at 75. I guess 11, so you can be able to see that on here. So that math works out pretty well. Half the voltage and half the amperage I would expect. Turn this off. Now, not really going to be able to test higher amperage, I think. It could try and generate a little bit of a higher voltage, but I don't have anything that can do that for significant amperage. I have 500 volts in one of my capacitor testers, but I don't want to put it through this necessarily. So flip this around and test it the other way. Just make sure both LEDs work. So that's on. And this is live. Be careful. Alright, and that one is a little bit less visible, especially in the low range, so I think I need to move that LED, but you can sort of see it there. There's something going on in there. So yeah, that is one contained resistive capacitor discharge box. Got the power supply here. Get the meter out of the way. Pretty simple project. Pretty simple to use. Plug on either end and switch in the middle. Need to label high and low and adjust my LEDs so they line up better. You can sort of see one of them sitting in there. Maybe you can see it, maybe not. The other one, barely visible even when it's on. But definitely works. Appears to work correctly. So shrink down the heat shrink, fix the LEDs, and get this collar back on the switch. Make sure I don't lose that. Yeah. Nice and easy project. Post everything on GitHub to go along with it. Thanks for hanging out.